Math 30-1, we're going to do some transformations of exponential functions today. I just got to remember a few different things about transformations. If you've forgotten them already, hopefully you haven't. Remember that the a value here, let me just get my pen to work today. There we go. That your a value here does your vertical transformations, such as a stretch about the x-axis, right, about the x-axis, and a reflection about the x-axis. Your b value here will do a horizontal stretch about the y-axis, but remember it's reciprocal, so if that's like a 2 or something, then the transformation will be a half about the y-axis, and it could also do a reflection if it's negative. And then your h value here, will move it left to right, and your k value will move it up and down. So just remember that, but this form, this general form that we have here, can be applied to any function. It doesn't matter what function we're talking about. We've applied it to polynomials, rational expressions, radicals already. Now we're just going to, or quadratics as well. Now we're just going to apply it to exponential functions and just see how that goes. Most of this lesson will be kind of a review. You just have to kind of remember what are the key points of an exponential graph and how can you change them using these stretches. If you see here in this form here, we have an A that's just sitting in the front here. The B, the H, and the K, they're all in their respective spots. Just remember that all of this B bracket X minus H, it replaces where the X usually would be. And you notice that in a regular exponential function, the X is in the exponent. So all of that becomes the exponent. Okay? The C value, there's nothing up here to deal with the C value, the base of the exponential function. So when we're doing that, the C value is the function itself. Okay? It's the type of function, decay or growth. So you can't change the base value. The base value just stays the same. So this base value here, you can see on this example, number 1 here, the base value is 4. And then we're going to do a few things, such as a vertical stretch by a factor of 1/2 about the x-axis, which makes sense. A horizontal stretch by a factor of 2 about the y-axis, and a reflection about both axes. So we're going to do a reflection over both, and then we're going to do a few translations here. Okay, so I want to know what the function g of x looks like. So I'm going to use the function notation to start off with. Just going to plug everything and make it look like what's up here. I'm going to use that down here. So I'm not going to actually use the 4 to the power of x yet. So I got this vertical stretch about a vertical stretch by a factor of 1/2, and a reflection about both axes. Sorry. So that means I know my a value is a negative 1/2. I know my b value because I did a horizontal stretch by a factor of 2, and a reflection is also negative 1/2. So remember that one does that reciprocal. So the b value is 1/2, even though the factor is 2. My h value, since it moved on left 5 units, my h value is negative 5. And my k value, 7 up, so that's just 7. So I'm going to plug this all together and just make a function notation. So I'm going to put my a value here, f, but I will replace this and put the actual equation later on. But right now I'm just going to put the pieces in. So negative 1/2, x minus minus 5, so that turns to a plus 5 here. And then at the end of the function, I'm going to say plus 7, and move that 7 units up. So my new function, the actual equation, if I wanted to graph this, would be negative 1/2, bracket 4. So you can put both these in brackets, but keep them separated because they are 2 different pieces. I can't multiply these together and expect to get negative 2 because this one has an exponent and the other one doesn't have the exponent. They both have the same exponent. Yeah, combine them together. See what happens. All right. So remember that the stuff that's inside the function, that's inside the f notation here, becomes the new exponent because it replaces the x. So I'm just going to write that as the exponent and then plus 7 out over here. So there's my equation for this graph. It says here, express the mapping notation. So if I start off as x and y, what does that become? So what we know about what's happening to the x's, we're doing a factor of 2 and a reflection. So I'm going to times all my x's by 2, and then I moved it left 5 units, so that's a minus 5 in there. What else do we have? So we got the y values. So we're doing a vertical stretch of a half and a reflection. So that's negative 1/2 y and 7 units up. So that's what that would look like. So we can now apply this transformation here. Oh, sorry, just 1 second. This is a different program. Right. So I want to apply the transformations to this point here, 216. So I can put those into the mapping notation above. So if I were to put that 2 in there, I get 2 times -2 times -2, or -2 times 2, sorry. And then also have a -1/2 times 16, and then I get plus that 7. Plus that 7. Okay. So we do some mental math here. So it looks like I'm going to get -4 minus 5, so I get -9. And then I get -1/2 times 16, so that's going to be -8 plus 7, so I get -1. Okay, so there's my new point. So this next one here, we just want to kind of sketch what this graph looks like. Sometimes it's nice to try to sketch what the graph looks like before we talk about what is the descriptions. Sometimes it's better to talk about the descriptions first. So I'm actually going to do B first, and then I'm going to talk about drawing the graph, talk about the key points. Remember the horizontal asymptote of an exponential function, the original y-intercept of 0, 1. So we can use those to solve this question or help us sketch this graph. Okay. Come on. There we go. So I'm going to describe the transformations. So we have this -1/2 sitting in the front. So this -1/2, we'll do a vertical stretch and a reflection over the x-axis. Because it's doing this way, right? So we're going to do this over the x-axis. So we got a vertical, let me write this out, a vertical stretch about the x-axis, kind of writing this in a weird order, of a factor of 1/2. You can see there's a 2 here, but you notice that this is kind of written in the incorrect order or incorrect form. So I'm just going to rewrite this. So we're going to factor this 2 out. The 2 doesn't change. So we still have a horizontal stretch by a factor of 1/2 of the y-axis. But it's going to change this 6 into a 3. So it's going to change it. Rather than moving right 6 units, it's actually going to move right 3 units. So we have a horizontal stretch about the y-axis of a factor of, what do we have here? 1/2. Okay. Then we're going to have a vertical, or just a reflection. I'll just call it reflection, a vertical reflection, but a reflection about the x-axis. You see that there's a negative in front of the half here, so that's the vertical stuff. So it's going to do a reflection over the x-axis. Then we're going to have some translations here. Translations, 3 units to the right and 5 units down. So knowing that, now we can actually draw what this graph looks like. So first of all, the original graph, let's just think about the original graph. So my base here, oh, that's a big thick pen there. I don't want to use that, such a big one. Yeah. Let's change it to that one. Yeah. So my base here is 2. Right? So I'm going to draw my original graph in red here. So my base is 2, so that means that every increment of x, my original graph would have been times 2, times 2, times 2. So I started off at 0, 1. So this is going to be my original graph of 2 to the x. So I put a 0 in there. 2 to the 0 is 1. Then 2 to the 1. Then 2 to the 2. Then 2 to the 3. So this graph looks like this. That's what my original graph looks like. And then it's going to go backwards the other way. So I'm going to 1/2, 1/4, 1/8, and we have a horizontal asymptote there. So my new graph is going to apply all these transformations here. So we had a horizontal asymptote here at y is equal to 0, but because I moved the graph down 5 units, I'm going to have a horizontal asymptote at y is equal to -5. Okay? And what else do we have here? We got a few other things going on here. So we have a vertical stretch by a factor of 1/2 and a reflection, right? So a vertical stretch by a factor of 1/2. So this point here is now 1/2. It squishes in and then reflects over to this point, then move down 5 units. So we're down to here now. And it moved over 3 units to the right. Right. It might just be easier if we try to do a mapping notation. So I just pick some random points and apply the mapping notation to it. So I got a bunch of key points here. These key points here. I can apply all these key points and make some new graph points for this one. So what do we have here? So we have a 1/2 x plus 3. That's going to happen to all my x values. And then my -1/2 y minus 5 for all my y values. Okay, so this point here, if I were to put that back in red, this point here is 1, 2. This one here is 2, 4. And this one here is 3, 8. Okay, so I can apply these points here. Okay, so I put a 1 in here, 1/2 plus 3. 1/2 plus 3 is 3.5. So my y value is going to be, well, my x value, sorry, is going to be 3.5. So somewhere right about here. And then I'm going to apply my 2, so I got -2, that's 6. Yeah. And then I'm going to do the same thing with the other point. So 2, let's put a 2 in there. We got 4. And what do we get there for that one? We get -7. Then I do the same thing with the other point here. 3, 3, 3/2, so 4.5, so right about here. And 8, -4, -9, right about here. So this is my graph looks like now. Yeah, and then this point's going all the way over here. Okay, that's my new graph. We call that g of x. That's like what. Now, what's the domain range of both functions? So you notice that the domain didn't change. XCR for both these graphs. And my range is now going to be less than, like you could determine that from before, because we did a reflection over the x-axis here. So rather than greater than, it'd be less than. And because I moved the graph down 5 units, that's be less than -5 y ER. Okay. It says identify the intercepts for both graphs. And now there's no x-intercepts for both these graphs. You notice that both of them don't cross the x-axis unless I shifted this one down slightly, not reflecting it. So I have no x-intercepts for both these graphs. But my y-intercepts, so remember to find that, you make x equal to 0. So we're just going to do the math, and we're going to say x is equal to 0 for both of these. First graph, the 2 to the power of x graph, that's a pretty easy one. If I put a 0 in there, I get 1 out. And my other graph here, so if I put a -1/2, 2 to the 0, 2 times 0 minus 6 to the -5 at the end. So now I'm just going to put that on my calculator. Put my calculator here. So -1/2 times 2 to the power of -6 minus 5. So it's not a very nice number. It's close to -5 though. But we get a point that says 0, -5.01 approximately. So it ends up being approximately, when you do the math, 5.0078. So I'm just going to round it to 3 sig digs there. Cool. Okay. So now what we're going to do is we're going to apply or we're just going to describe the transformations and write the new function for this one. This is a pretty self-explanatory, pretty easy question here. So we got all these things that are happening here. So we have a vertical stretch by a factor of 2 about the x-axis. There's no reflection this time in the x-axis. Oops, maybe I should write the x-axis there. But we do have a horizontal reflection and a horizontal stretch. So let's write those out. By a factor of 4. So remember that the b value is a quarter. Well, you got to take the reciprocal to get the factor about the y-axis. Sorry about the writing here. And we have a reflection about the y-axis. Okay. You notice that this is already in the correct form. Someone's already factored out the negative quarter for us. So when we do our translations, we don't have to worry about that. So then we translate 8 units right and 3 units up. Okay, so we described the transformations. That's what we did. And then we're going to write the new function here. So we're just going to apply all of this, taking out the f notation and applying it to this function here with a base of a half. So my new function, we can call it g of x if we wanted to. Let's give it a name, is equal to 2 times a half raised to the power, and all of this stuff here, remember that all of this was originally this x here, because they used to say f of x, but now they replaced it all. So all of that now is my new exponent, and then plus 3 at the end. Okay. Oh, I'm going to sneeze. Okay. Describe the transformations that would produce this graph or this equation down here. This graph is in the wrong spot. That graph should be just below here. For example, 5. I don't know why it's in the wrong spot. That says for the graph below, but it's actually for this graph here. There. So this one I should say above. Okay. Before I start this question, though, what I should do now is I should isolate for y, because that's usually how we describe our transformations or figure out how does this plus 5 and this negative half here actually do anything to the graph. So I'm going to apply these, or I'm going to just move everything around. So I'm going to times the negative 2 up to the other side here. So we've times the negative 2 up, and then I'm going to minus this 5 over. So again, I'm going to get rid of this negative a half. I'm going to times the 2 up to the other side and then minus the negative 5 over after I get rid of what's in front of the brackets. You could multiply the negative half into the brackets and then move things around, but that'll just cause a little bit of confusion and problems later on. So it's best just get rid of what's in front of the brackets first. And then I notice that the exponent is not in the proper form. I'm going to factor that 2 out. And now I can describe the transformations that we have here. So what do we have here? We've got a vertical stretch out the x-axis of a factor of, what do we have? A factor of 2. We have a horizontal stretch about the y-axis of a factor of, remember the b value is 2, so you get just the reciprocal of that and you get a half. Then the a value is negative, so that means I also have a reflection here about, because it's the a value, about the x-axis. We're going to do it this way. Okay. And then we got the 3 and the negative 5 here, so we're going to do, I just like to write the word then we're going to translate 3 units right, and 5 units down. All right, those are our transformations.